Now we're going to keep looking at circles, and we're going to start looking at angles that are inside circles. So to start with, let's review the parts of a circle. So we have the radius, which goes from the center of the circle to any point on the outer edge of the circle. We have the diameter, which goes from one side to the other, and it goes through the center. It's got to go through the center. The center of the circle is the one that's equidistant from all of the points on the outside. And a chord goes from, or it's a segment where both endpoints are on the circle, but it doesn't necessarily have to go through the center. So a diameter is a chord, but a chord does not always have to be a diameter. So over here on this circle, these green segments are chords. All right, then we have a minor arc and a major arc. A minor arc is less than 180 degrees, right? And then a major arc is greater than 180 degrees. And we label these using an arc or a curve over the top. Just like before when we would say segment AB, now we might say arc AB with an arc over it. Right, now a minor and a major arc, they are two different things. And remember, a circle has 360 degrees in it. So for example, this arc here, AB, would be a minor arc. So I would say AB, right? Because this is going to be less than 180 degrees, because it's less than half the circle. Then the arc that goes around the outside is going to be our major arc, and we label that one with 3 letters. You always have to do a major arc with 3 letters to differentiate, because if I said AB and I meant this direction, you could also see AB as a minor arc. So the minor arc is arc AB. The major arc would be either ADB or BDA. Doesn't matter what order. Oop, and that's our major arc, BDA. So a minor arc is less than half the circle. A major arc is over half the circle. Okay, central angles are angles that are on the inside of the circle, and their vertex is the center of the circle. Okay, so as long as the two segments are coming out of the center, it is considered a central angle. The central angle is the same degree as the arc. All right, so the central angle and the arc are the same. All right, the arc measure. An inscribed angle is another one where the angle's on the inside, but the vertex is on the edge of the circle. Okay, and then the inscribed angle is the same as half of the intercepted arc. So it's the intercepted arc divided by 2. And we can actually go back to that central angle and say that it's the same as the intercepted arc. That's like the nice term to use. Right? And then this red one here, this is our intercepted arc. So they're the same. Then an inscribed angle is half of the intercepted arc. So a couple of examples. Right? I want to find the measure of arc RS. So RS is here. And I know that my central angle is 60, so that means arc RS is 60. Right? Then RPS is going all the way around. That's a major arc. Okay, and I know that all the way in a complete circle is 360 degrees. So if RS is 60, the rest of my circle is going to be 300 degrees. PQR, right? PQR comes around here. I know that this is 40, this is 60, this is 120. So that's going to be 220, which 360 minus 220 is 140. So then PQR is 140 plus 40, which is 180 degrees. QS is going to be the smaller one because it's just 2 letters. So QS is 40 plus 60, which is 100. QSP is 3 letters, so it's going to be a major arc. So that's 120 plus 60 plus 40, which is 220. And then QTR is an angle. So QTR is this way. The intercepted arc is 40. It's a central angle, so it's going to be the same. And it's also 40 degrees. Right, then we got circle P here. We want to find the measure of the red arc. Okay, so that means this is a diameter because it cuts through the center and goes from one end to the other. So that means that this whole section, BCA, is 180. Right, so that means that x plus 2x minus 30 has to equal 180. So x and 2x is 3x. Add the 30 over and we get 210. Divide by 3 and x equals 70. All right, I want to use that to plug in to find the measure of the red arc, which is this BC here, 2x minus 30. So we got to do 2 times 70 minus 30, which is 140 minus 30, which is 110 degrees. For the second example, I know that AB and MN are diameters because they go through the center. So that means that each of these sections is 180. So I'm going to use this x over here, AM, and the 4x to figure out 180 degrees worth, so I know what x is, and then I'll plug x into 4x. All right, so then I'm going to say x plus 4x equals 180 degrees. So 5x equals 180 degrees. Divide by 5, and we get 36. Then plug 36 in, so 4 times 36 is 144. So our red arc is 144 degrees. And then we're back over here. I want to find this big arc here, right? And I know that all of these added up together have to equal 360. So we have 7x plus 4x plus 6x plus 7x equals 360. So 7 and 4 and 6 and 7 is going to be 24x. And then 360 divided by 24 is 15. And then I want to know the red one, which is 6x plus 7x, which is 13x. So 13 times 15 is 195. So that one is 195 degrees. And for our last set of examples, we're going to go back to the inscribed angles and the central angles. So for this one, 47 and x are both inscribed angles. So remember, inscribed angles are half of the intercepted arc. So in this case, both of those angles intercept to the same, or they have the same intercepted arc. So that means that x and 47 are the same. So it's going to be 47 degrees. Okay, for the middle one, I know that this is a diameter because it cuts through the center and goes from one side to the other. And then these are all inscribed angles. So that means that this arc here is 2 times whatever y is. This one is 80, 2 times 40. And then this one's going to be 2 times x. Well, I can find the x easily because this is a diameter, which makes this half of a circle, which is 180 degrees. So that means that 2 times x equals 180, so x equals 90. So I know that this is 90 degrees. And then this is a triangle, so that means that they have to add up to 180 degrees. And so 90 and 40 is 130, and then 180 minus 130 is 50. So that means y equals 50 degrees. And for the last one, I don't know that this is a diameter because it doesn't necessarily cut through the center. It could, but it doesn't tell me that, so we're not going to assume. All right, and I know that this angle here is inscribed, so that means that my arc is double that, which is 90, which I guess I should have a color. So I have 90 degrees for that arc, right? This one is 2 times y, whatever that is, right? This is also 2 times x, and then this one is also 80. Because of the 40 that opens up to it, and then the x opens up here. So now I have my two equations. I know that 2y equals 80, so y must be 40. And then 2x equals 90, so x must be 45. All right, so your inscribed angles are half of the intercepted arc, or the intercepted arc is double whatever the inscribed angle is. And then your central angle is the same.